Lesson 3. Work, Potential. Section 3.3. Conservative Property. In exercise 3.1.2, the work done in moving an electric charge through path 0, and that done through path 1, path 2, and path 3, were the same. In exercise 3.2.2, the work done also did not depend on the paths. These cases suggest that in an electric field due to a point charge, the total work is determined solely by the endpoints of the paths. Suppose there is a point charge positive q coulombs at point P0. Suppose we push a unit charge from point P1 to point P2 along path 1, in the electric field due to positive q. The differential work dW is given by negative E dl. Theta denotes the angle between dl and E. Then dl cosine theta is the component of dl, directed toward positive q. dW is written as E dl cosine theta. At any point on path 1, dW is expressed as E dl cosine theta. Note that dl cosine theta component is always directed toward positive q. This is a straight path from P1 to P0. P3 denotes this point. Point P3 is rotated around point P0 until it reaches the straight path. The magnitude of E' is equal to that of E. Thus, if the displacement of P3' toward P0, that is the magnitude of dl', is dl cosine theta, then the differential work dW' is the same as dW. Therefore, the line integration of the differential work along the path 1 from P1 to P2 equals that along the straight path from P1 to P2'. Both P2 and P3 are located r2 meters away from P0. The distance between P1 and P0 is r1 meters. Then the result of the line integral is derived as shown in this equation. The result of the line integral along the path 2 is also the same. The result is determined solely by the endpoints of the path. In this case, P1 and P2. A field like this is called a conservative field. The electric field due to a point charge is conservative. If R1 goes to infinity, then the potential V2 at point P2 is determined only by the distance R2. This potential is independent of the path from infinity to P2. If a path in a conservative field is closed, then the line integral becomes 0. To emphasize that the line integral is along a closed path, the integral is written with a circle on the integral symbol. If this integral value holds for any closed path, then the field is conservative. Exercise 3.3. This is your homework. This is a conservative electric field. Pause the video, and answer the problem. The author of this material is Takeshi FURUHASHI, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.